Hi folks, we're going to take a look at number 15 on page 419. So they tell us that ABC is an isosceles triangle with B and C being the equal sides, and they want us to show that this equation is true for cosine of A. All right, so here we've got some isosceles triangle. Okay, so if this is B and C and they're equal, um, this is going to be side A, and so capital A is just the angle opposite it. All right, so since we have information um, about the three sides. Okay, these are the two equal ones. This is the non-equal one, and they're looking for cos A. Well, looks like we're going to have to work with the cosine law. All right, so since we're looking for cos A, I'm going to use the side opposite it, little a, as my variable on the left-hand side. So if we apply the cosine law to this triangle, we have that a squared is equal to the sum of the square of the two other sides. But here, remember, side C is equal to side B, so I'm just going to use the same variable for both. So b squared plus b squared minus 2 times the product of those two other sides. So again, b times cosine of the angle opposite the A. All right, and so now it's just a matter of doing the algebra and see if we can come up with this formula. All right, so what I'm going to do is, in order to make this positive, I'll bring that whole expression to the left-hand side. So it's going to be positive 2b squared cosine of A equal to, so this is going to be 2b squared, okay, and now I'm going to subtract a squared to the other side. All right, so now I want to isolate the cos A, so I'm going to divide both sides by 2b squared. All right, so we have 2b squared minus a squared all over 2b squared, okay. So this doesn't quite exactly look like what I'm trying to prove, so I still have to do a bit more algebra. And what we see here is I've got this subtraction in the numerator, so I can write this as two separate fractions. I can rewrite this as 2b squared over 2b squared, so I'm just distributing the division, minus a squared over 2b squared. But now we see that something very nice happens. These are the same, so they just reduce to 1. So we have 1 minus a squared over 2b squared. All right, and there you have it. So just to recap, I just set up a diagram and I realized that I was going to have to use cosine law. So it was just a matter of inputting what I knew and then doing as much algebra as I could until I get to proving that these two expressions are indeed equal. All right, so now in B, they want us to solve this triangle, meaning find all the information about the triangle given this information here. But essentially, they've given us all three sides, okay? And instead of using cosine law, I might as well use this formula, which I just found. Already did a lot of simplifying for me. So if I'm looking for the angle A, so essentially I'm just missing the three angles here. So if I'm looking for the angle A, I can just input the information that I have. So I have that cos A is equal to 1 minus, in this case here, side A was 0.8, so 0.8 squared over 2 times B, side B squared, which is just 1.5. All right, and of course, to calculate the angle, I just take inverse cosine of that. So inverse cosine of 1 minus 0.8 squared over 2 times 1.5 squared. And you notice how I leave everything till the end because the calculator can handle all this, so I might as well not approximate as I go along. All right, so here we have inverse cosine of 1 minus 0.8 squared. Now, because I've got a few things happening in that denominator, when I divide, I'm going to open up a bracket just to make sure that the order of operations is correct. So we have 2 times 1.5 squared. And here we have 30.9. So A is equal to 30.9 degrees. All right. So now I just need to find the other two angles, but because this is an isosceles triangle, these two angles are going to be the same. So I actually don't have to do much more work. I can just say that the angle theta, which represents the other two angles in the triangle, is just 180 minus this 30.9 and divided by 2, since what remains is just going to be two equal angles. All right, so let's calculate that here. So we've got 180 minus 30.9 equals divided by 2, and we have 74.55. All right, so theta, the two thetas are equal to 74.55 degrees. Okay, so here I just essentially used the formula that I had just found, that I'd already simplified, to help me solve the triangle with the particular side lengths of 1.5 and 0.8. Okay, that's it for this one.